Grid.
Okay, I am back on stream. Okay, so basically, while you were getting ready to go there, I was implementing a sum function because we'll be using that a bunch, so that instead of this TL fold thing, I can just do TL sum, and it should all just work in theory.
Ah, that's cool. I think I can use a camera that is just both of us. Oh. I, I really wish I knew how to just drag the pixels. Like for the cropping and not selecting. There we go.
Alright, I made a mistake on my sum implementation because I used iter value t in my range-based version as well. I can't remember what the name of the type trait to get. The ranges iterator t. Is that right? Ranges range value t. Stood ranges range value t.
That's
r.
That's a lot of rangers.
It is.
They don't say.
Ranges.
Not many lone rangers there. Here we go. Oh, well, that's good. That one. Don't crop from the left. Crop from the right. Maybe only 900.
This looks like it's building fine. Yay! And let's make sure that I get the right answer again.
Oh, I'm being silly here.
Part 1 was something like 10,000 and something. What's going on? Yeah.
Yeah, this is gonna have to do
Okay.
for today, because.
Cool. Well, I'm all ready to get started whenever you are.
Yeah, I'm.
I've got a cat.
Cat.
Kitty. Wow. She doesn't want to say hi. There we go. Everyone say hi, lexical cat. Oh dear.
Do you have a semantic cat?
No, just a lexical cat.
All right, I think I'm starting now. All right, friends, we're back. This is day 3. Dear Lord, these elves are gonna kill me. All right. We're doing Advent of Code 2022. I'm doing it in Julia. Sai's doing it in C++ and the really powerful ranges library that we're trying out. Yeah. So you got already part.
No, I've just been playing around with my ranges stuff. So I haven't even read the description yet, so I can go ahead and give
fantastic.
that a read.
I'm only going to use the Julia REPL today, I think.
Okay, cool.
Don't. Let's see. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions. Big mood. And so a few items now need to be rearranged. Each set rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly one type per item. I see a partition coming. The elves made a list of all the items currently in each rucksack. With unusual help finding the errors, every item type is identified by a single lowercase letter or uppercase letter. That is A, and A refer to different types of items. A list of items for each rucksack is given as characters all in a single line. The given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent. I say the first compartment will the second. For example, suppose you have the following list of contents from 6 rucksacks. Blah, blah, blah. All
Yeah.
caps and
Lots of
in,
mess.
in lower cases. Yeah. The first rucksack contains the items blah blah blah, which means it's the first compartment contains the items. The second compartment contains the items.
Okay. So we
You'll need to have
split it in half. Find which element from the first half also exists in the second half.
Wait, but it's like how does it split?
It's split right down the middle.
Oh,
So,
it's the middle
given,
of the.
a given rucksack always has the same number of items in each of its 2 compartments. So split right down the middle means that they should all have an even number of elements in them.
Got it. Thank you. The only item type that appears in both compartments is lowercase p. The second rucksack's compartments contain blah 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 and other blah blah blah. The only type item that appears in both compartments is uppercase L. So P, then
Cool.
uppercase L. No common item is uppercase P. The first.
We find the shared element between both halves, and then.
To prioritize item arrangement, every item type can be converted to a priority. Lowercase item types A through have priorities 1 through 26. Uppercase items types. In the compartment, the priority of the item type that appears in both compartments of each rucksack is 16, 38, 48, 22, 20, and 19.
All right.
And some of these is full.
So we read in all of the lines, we split down the middle, we find which
the common thing
is the
and
common
reduce
thing,
on that.
and then work out the value of the common thing, and then sum up those values. Seems reasonably straightforward.
Yeah.
We'll give it a shot.
All right.
All right. See you on the other side. Okay. Let's get started. So we're gonna do get lines. I should maybe just add this to my my template since we've been using it each time. So our lines will be till fuse get lines of our input, and then for each line we're going to do something. So we're going to do a transform for each line. We're going to score that line. We'll get the priority for that line. We'll call it score line. And then we're going to sum up the scores. Call this scores. And semicolon. Okay. So our score line, we'll just return an int. It's going to take us to string with the line. We're going to split it down the middle and find which is the common element. I'm sure there must be an algorithm for this, like one of the find variants. What we got? Find if not, find first of, searches for any one of a set of elements. That sounds like what we need, right? Searches the range first to last for any of the elements in the range first to last to. Okay. So we can just do std ranges find first of with I'm gonna take the, we could do substring, we could do our midpoint anyway is line.size divided by 2, and because they should have equal number of elements, then it should be even, and then we can just do line.subster 0 to midpoint, and then this midpoint plus 1. And line dot. Oh no, that's the count, isn't it? Dot substir midpoint plus 1 to the end line. No, this is a count, isn't it? So it will be midpoint again. Is that it? And this returns an iterator. If I hit insert, yes I have. Common is that. And then we get the priority. The priority of a character C, which is if its std is lowercase, then what was it? 1 to 26. So if it's lowercase, then return character minus a plus 1. Otherwise, return character minus capital A plus 1. And return the priority of find first of returns an iterator. Let's give it a shot. Build succeeded. Nothing to do. That's not what I expected. Let's rerun CMake. Anyone notice anything obvious I did wrong while this builds? I feel like I'm just asking for an off by 1 error with this substring nonsense. Missing semicolon line 7. Yes, thank you. Okay, find first of is not a member of std ranges. What are you talking about? Does MSPC's library not implement std ranges find first of? Since C++20, I thought we were... I am confused. Well, I guess I can just use the algorithm version. Oh, is it because it's in the algorithm header, not the ranges header? Whoops, what did I just press there? I just ran day 2. Yes, that was it. I was very confused there for a second. Illegal indirection. Oh, does this not return a... Oh, this is saying it's a dangling pointer because first half is this. Because I'm getting a... I was just doing a substir and then getting a pointer back to my substir, and it was returning me a dangling pointer. And actually caught that at compile time. That's very nice. Whee! Okay, let's try that. Sum is not member TL because I didn't actually include TL fold. Built. Let's run it. We need some input first. Let's use this. And run. 105. Is that correct? 157, that's not correct. Okay. What did we do wrong? Let's print out these halves just to make sure I don't have an off by 1 error. let's stick a new line in so that we can actually see the differences. Yeah, saying we while coding is the correct way to do coding. Thanks for the follow, I'm Siva. Shouldn't the second half start at midpoint and not midpoint plus 1? You're probably right, yeah. Yeah. Std print isn't in there yet, no. C++ 23. Oh, the priority calculation's wrong? Wait, let me just make sure that I didn't have an off by 1 here. Ooh, what was this? V to R and then C to P. Yeah, that was I did have an off by 1 error there. Priority calculation is wrong, you say. Let's do C out of our common and then our priority or common. Did rest saying shouldn't end at end rather than midpoint. Yes, this is a size rather than an end point. So you give it a offset and a count is how subster works. Oh, plus 26 for capital letters. Yeah, thanks. It's a plus 27, right? Or is it 26? Yeah, plus 27. Okay, so we get P 16, big L 38, 42, 22, 20, 19. That looks correct to me. 157. Yep, all good. Okay, a few little mistakes there, but we should be good to go. Okay, 8,493. Give that a shot. That's the right answer. Yay. Let's get rid of that print statement as well. Sweet. Alright, let me just tell Miguel that we are done with the first half. Hey, we're done with the first half. Gonna move on to the second half. Okay. Second half. What's going on? As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Each elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item carried by all 3 elves. Okay? That is, if a group's badge... Yeah, Miguel was muted. That was not me. For efficiency, within each group of 3 elves, the badge is the only item carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on their badges. Naughty naughty. All of the badges need to be pulled out of the rucksack so the authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first three groups rucksacks are the first three lines, and the second group's rucksacks are the next three lines. Okay. In the first group, the only item type that appears in all three rucksacks is lowercase r. This must be their badges. In the second group, their badge item type must be Z. Okay. So we can't use find first of anymore. Because we need to find basically all of the, like if we compare the first group against the second group, we want to find all of the values which are shared, and then we want find first of on the third group. That would work. Is there something which does that? Some algorithm which will copy the shared values between two ranges into some third range. I'm not seeing anything. Does anyone in chat know if there's something which does this? Oh, the set operations. Ranges set intersection. Constructs a sorted range beginning at result consisting of elements that are found in both sorted input ranges. If some element is found m times and n times the first minimum. This sounds like what I want, right? We can do a set intersection on the first two values and then a find first of on the third list. It seems reasonable. Let's give it a shot. Okay, so part 2. We're gonna... Wait, what was the end value? Summing up the priorities. Oh, chunk 3 and set intersection. Can you do a set intersection on 3 ranges at the same time? Or you mean just doing one set intersection and then set intersection on the second, between the result and the third? Anyway, we can do a scores equals TL views get lines. So we're gonna get lines, and then we want to get in chunks of 3, so we can use std views chunk 3. Thanks to the follow hongbd6. And for each chunk, for each group, we're gonna do std views transform score group, and then sum up the scores. Okay, so we do a int score group. Thanks to follow Lewis C 1968, and this is a group, and its type is long, so unnamed. You can use, if you hit Alt F1, then it decorates your types. But if they get too long like this, std ranges transform view of get lines view of remove reference to, then it kind of falls apart a little bit. But anyway, for each group, we're gonna get the first value and set intersect it with the second one. So what's the best way to just get the first second and third things from a range without like iterating over it. Taking the... Cool, that's Miguel just telling me they're on, he's on part 2. Cool, we're on part 2 as well. Okay. Yeah, in fact, I think we made the double tap control thing. We removed it, or at least made it configurable, because a lot of people were just hitting double tap control as part of their regular programming, and it was triggering, this thing all the time. So people sent us bugs. They didn't like that. Thanks for the follow, BF Viper. Okay, well, we can get, I guess, the oops, get an iterator, and the first group is so we want to do a set intersection and stick our results into a vector of chars, and that's going to be std ranges set intersection of begin plus begin, and then we do return, well, a common item is going to be std ranges find first of between the result and our next group, and then we're going to return the priority of common. Let's give that a shot. No matching call operator found. What am I doing wrong here? Oh, does this need to be... We can't pass it by value. No. What's going wrong here? No matching call to transform views, could not deduce template argument for our function. Oh, because this is a template. So I actually need to, I can't just take the address of this. I can do, pass it a closure instead. That's better. Okay. Call to set intersection, not found. Do these need to be, I'll stick these into temporary. Group 1 is, again, group 2 is see if this gives me something different. You know what, I'm just going to stick this into a vector. Oops. Okay, so this should just give me a vector of 3 strings each time. And then I just do group 0, groups 1, groups 2. We do love vectors. Hey Oliver, how's it going? Still, what am I doing wrong? Oh, I didn't pass it my stood back inserter to result. It helps if I pass the vector that I actually want the results in, right? There we go, that's more like it. Dereferences. Yay. Okay, let's run it. Oh, debug assertion failed. I did a bad. Can't dereference value initialize vector iterator. That's not fun. Okay, it didn't find our... Okay, so what's in result? Empty. Well, that's not really what I want. Okay. You know, let's give this the test input just so that we can have a bit more information to go on. Okay, so we got the same error, and so we should be getting, where are we? The V, the J, the capital P as our groups. Oops. Groups, V, the J, the capital P. And then the set intersection should be giving us, what should this be giving us? The only item which appears in all 3 backpacks is lowercase r, and lowercase r. So why is set intersection not giving me lowercase r? Am I using set intersection wrong? Constructs a sorted. Oh, sorted. Groups 0. $70. $70. That's better. Okay. Let me just do a little bit nicer. Okay, and let's try this with our proper input. $2,552. That's the right answer. We did it. I made a lot more mistakes this time than the last couple of times, but I think the solution's kind of nice. Set intersection is a nice algorithm. If we could do set intersection like groups 2 and do everything in like a single call, that would be pretty cool. But it works pretty well. I think All right, let me tell Miguel that we are done. Hey, we're done. Gonna. You should all be able to see Miguel's screen now. Let's follow him along. Can you unmute yourself on Discord, Miguel, so that we can hear you? Thanks.
Sweet. Yeah. I thought I was going to do something really clever. So what I did was I had my working thing from part A. And then I was like, hey, there should be something that like, so biggest idea, biggest galaxy brain in the world, right? You just do, or the stirs in iterators.take 3 at a time.
Yeah, that's what it is.
Put them all, or try to put them all into a set, find the common one, get the lone person, and apply the priorities and reduce. This is, I believe the fancy name for the algorithm is a segmented reduce in different levels of bucketing. Because I saw it in the Futhark chat. Shout out to the Futhark array length.
Okay.
So if you've never heard of Futhark, it's just like the most bonkers cool idea ever. It's like if the Haskell people actually built like a good MATLAB and they went full in on the parallelism budget. It's just like all the cores for all the cores.
You know, I did parallel Haskell for a bit at university, and I remember this is one of the formative moments of programming for me.
This is canonical silo. I'm here for this.
Yeah. So I can't remember exactly what the thing we were supposed to be doing was, but it was implementing some kind of mathematical function which we wanted to distribute on across a relatively big machine. And Parallel Haskell uses this thing called, I haven't touched it in literally like 10 years or something, so I don't remember a lot of it. But as I remember, it uses this thing called Sparks, where you can basically create as many sparks as you want, which are like kind of logically threads, i.e. there's some unit of computation which you want to have completed at some point, and you think that these things can be parallel. And then there's a runtime which sits underneath, which looks at all your sparks, of which there might be, thousands of thousands, and actually maps them onto your available hardware parallelism.
The actual runtime scheduler, I guess.
Yeah. So it's quite a nice model, and it was very nice to work with. But I wrote my solution, and I was like, hey, this is pretty cool, and it runs pretty fast.
Did you mention the problem already, or
no,
it was some mathematical thing?
It was okay. I can't remember what the problem was exactly, but so I was like, well, I should maybe profile this and make sure I'm actually using all of the parallelism available to me, and that it's the scheduler is having fun and doing everything well. And so I profiled it, and I got this like thick blue line. It was like, damn, perfect, sorted. Like nothing else going on. But then I looked a bit closer, and I zoomed in to this
oh yeah, like when
line.
you start zooming into the profiler.
Yeah, and realized that it wasn't actually just a continuous blue line. It was a mostly continuous blue line, split up by little bits of green. And the little bits of green was when it was actually doing processing. Any guesses to what the blue was?
Garbage collecting?
Yes, exactly.
Haskell strikes again. Haskell. They had such a chance to be like, I think Stefan Karpinski, one of the creators of Julia, was like, if Haskell hadn't dropped the ball so bad on having fast arrays and faster, like we would have not needed Julia. It's just like, why? They already know the types of everything. They could. So one of the key parts of like having a super fast language is not juking the compiler. And one of those is memory locality, which your cats have very kindly explained to us. So, and if you don't know what we're talking about, go and see Sai's videos about how cache locality is extremely important. Basically, you want to have close things computer-wise and operate on them as much as you can and not go really far into memory. Haskell knows the types of everything, but they went for uniform representation abstractly, which involves a lot of pointer chasing over inline, compiler friendly, like mechanically sympathical representation. Just like everything being friendly for compilers. They went for what was friendly for their maths instead of what was friendly for the compilers. And so it's just like, oh, everything is just boxed everywhere. And it's like, you're going to have the crap load of time just garbage collecting.
I mean, I
And for
think
some reason,
some of that's due to like the nature of the language as well, though. Like with it having immutability and still wanting to be able to like concatenate some lists together and not have to copy like the entire list somewhere, things like that. But yeah, there's
I don't know if
trade-offs
you've
all over the place for stuff like that.
I've seen, so if you've kept up with Lean 4, they've done some really interesting stuff for um, memory reuse. So they're, I think Coca does something different where they're like, oh, you're going to copy lists. We can prove you're never reusing this list again after this program is done. So that's just free real estate. And so
Yeah.
they have this really cool benchmark where there's like a very famous red black tree implementation in C++ where you have to update stuff all over the place, and it would lead to allocations. And because their garbage collector is smart enough to figure out, oh, we can actually skip all these ref counts, oh, we can actually like save on all these allocations, the code they write in Lean 4, which is like super Pascal style functional, blah blah blah, is as fast as, if not faster than, the C++ red black implementation. And you're
That's
like,
cool.
that's pretty cool.
Yeah.
All
I've
right,
got a question for
I'm
you in
talking
my
a lot.
chat. Is Lewis C 1986 is asking if Julia is inspired by Ruby and to what extent?
So parts of it are, because Stefan Karpinski was a big Ruby person before they came to Julia. And in fact, there is something that people will like. Let me see if I can think of something just now. There's something called do syntax. So you can do something like, hey, let's see, O3. I could have solved the problem this way, actually. If I just want to read, and then this syntax will be something like this: do stir, right? And then I could probably do it like that. Open, stir, and then split on no line, and then something else. But the point is, like, this do syntax, I think, is almost directly lifted off of Ruby. And there's a couple things about like API cohesion and the standard library that I know were informed by Stefan's time. Like, all right, I don't use do function a lot, the do syntax a lot, but when you do, particularly for when you're doing files stuff, so if you use the do syntax, this is basically the same as I'm just gonna show it.
So is this like kind of like a Ruby block where it binds the result of opening that file to stir, which is some kind of like closure block parameter type thing?
Exactly. So I think it was yeah. So if I have 1, 2, 3, 4, 5, and then I do X. No, that's the end of expression. Oh, I think I remember. If I do find first. So if you want to start doing like functionally stuff in Julia, you can get really far. So the find first function, you would pass it a lambda or an anonymous function, and then I would say, hey, if x, let's say x is equal to 3, right? Then it would return the 3. So you're sort of like delaying applying the lambda with this function. So you can do like a multi-line lambda, and do functions are very handy for that. But let's say that you didn't want to do that. You just wanted to, you can just curry the equals. So there's a couple functions that are overloaded so that you can just curry them. So equals, less than, greater than, occurs in, like, there's a few special case functions that are searchy functions that make a lot of sense.
So this find first, the first find first you've got there, the actual function call to find first there returns like a closure, and then the do syntax is a block which you pass it, and that evaluates the closure with that block as an argument, or?
Yeah, so these functions always take like this is the longer form of running the same function. Give me a second. This is our notation for lambda.
Mm-hmm.
So it's for an anonymous function. So you have the anonymous argument x is mapped to x is less than 3.
Mm-hmm.
So, or let's make it less than, I don't know, or greater than 2. Yeah. So it's like, oh, that's the third index or something.
Mm-hmm.
And so that is basically the same. Or if you, once you get like functional pilled, then you will be like, oh, that's just a curried greater than 2.
Yeah.
And it's the same. But
yeah, that's
you,
nice.
and so what's really cool is that if you have scalar functions, functions that apply to only a single argument, you can just call them here. So I could say, I don't know, actually I could do something like map reduce, let's say x is x squared, and then just reduce some plus, and then that will work. So there's a lot of functionalisms that you can just do really comfortably.
That's cool.
And they compile down to really fast code. And that's something that a lot of people sort of miss out. And you're like, hey, like how do I even know? And so you'd be like, oh, well, you could look at the assembly just here.
Oh damn.
Yep. Oh yeah. Oh
That's
yeah.
really
So
cool.
this is a bad example because it's like pulling in code. This is debug. It's, I don't know when they changed this. There we go. This one's a bit more interesting, but okay, it's still like calling, like not inlining the actual assembly I want. And so I'm like, hey, like I'm really interested in like seeing that I get all my SIMD flops. So this is like the big difference that people like don't get between Julie's just like sparkling Python and NumPy. Like it's over there. It's like, yeah, for undergrad assignments it might be, but like once you start getting into like the compiler engineering, that's where it gets interesting. That's where I got hooked. So you can look at the assembly code, you could look at the LLVM code, right? Oh yeah, that's supposed to be LLVM. It's not. So they're doing like this jump call or this function call and not like the actual interesting LLVM. Or you could do like, hey, like I want to see what it looks like once it's desugared. Like what is, and so that's what it looks like in internal Julia representation. Or you want to see, hey, I want to, like we do a bunch of really fancy, interesting data flow analysis. Can you tell me if like any of the data like data type flow analysis fails somewhere? And they're like, oh yeah, no, everything's inferred properly. We know the types of everything, so you're gonna have fast code. And so that's the cool thing. Like you have like these super high level, like Haskell-y sort of patterns you can reach for, like map reduce, like mapping anonymous lambdas and like reducing pluses and everything. And they are basically guaranteed, not basically, but like mostly guaranteed to compile down to really, really fast code. So that's why in Julia you can just get like sometimes, like we're not the code golfing kings or anything, but you can have extremely, what's it called?
Terse.
Fast, but yet expressive code. That's not like overly complex. Like I love my BQN and APL, but you do gotta like squint for it a bit, quite a bit.
Yeah, this is very cool. The ability to like just see the LLVM IR to me is very cool.
And that's something that's very cool. And here's something that I very much miss. Let's say, I've done this demo a few times. So if I do function ham, this is why I've done tutorials on the Julia REPL. If I do function ham and then I press up, that searches in my REPL history for the latest time that I've like a substring has matched. And I could do like, oh sweet. So I could do S1, spooky. Nope. Let's do. Somebody else was doing like a code demo, string 1. All right, doesn't matter. But the point is, you can have something like A B.
For people who don't know, this is Hamming distance, which is like a way of representing the the difference between two strings.
Yeah. And so if I do that, if I do a semicolon, it doesn't print at the end. I don't want to print like this huge long string. Right. So I could do. So this should be, they differ on 1 every 5 characters. This should be like, I think 2000, right? So Hamming S1, S2, bam. That's cool.
Yeah.
Oh, yeah. And so you can throw these macros. So that thing that I put on with that, every time you see an @ sign in Julia, that's a macro. Like this is explicitly saying, I'm going to modify the code in front of me. It's going to get superpowers or something.
Yeah.
So you can say like, hey, how long did this take? And it gives you the number of allocations and everything. But then people were like, just knowing the elapsed time, it's not good enough. So you really want to be able to say, hey, could you please go run this code, do some statistical analysis, make sure, like, do the setup, do the teardown, everything, just with this function. So if you do that, and because I'm recording video or whatever, it's going to take a little bit, but it does its thing, and there you go, 84 microseconds. And
So
you're like, no.
That including the spin up time for the entire interpreter.
So there's no interpreter anymore, because, and that's something that I forgot to demo just a line ago. Let me show this one. When you do @BTime or @benchmark, it's from a specific package. It does the proper accounting for, did this take long enough? Did this not? Like, repeat it a bunch of times. And so this is what you're seeing here. 10,000 samples with 1 evaluation.
Oh, nice. Yeah.
0 bytes here. Let me blow that up. There we go.
Yeah, having good tools for micro benchmarking is really, really hard, but having some tools to make it easier is always good.
And this means I blame this macro alone for having attracted the worst / best of performance junkies from across many programming language places. And so people would just be like, hey, here's this snippet of code, you can copy paste it from almost any REPL to another. And then it's like people just be like, oh, I lowered the allocations, like it's faster. Then they can look at the assembly, they're like, oh, this thing isn't firing, or this is. And so you just get like a huge community of perf junkies that the fastest way to accelerate Julia code is to tell people like, this was faster in MATLAB or Python. And then they're like, not on my watch.
Yeah. Or say no one can get faster than my code that I've written here. It's impossible. And everyone's like, well, let me let me have a go.
So let me show you one last thing that's important to note. This is the Hamming distance, where you just go along each character and you count the ones that are different and all that stuff. And that's fine, that works. But we could have also written Hamming like this. Ham2. So you have S1, S2, and then this is just a map reduce of where this is, you map not equals, you reduce with sum, S1 and S2. And so let's try and remember that the last one, the median was 93 microseconds, right? So Ham2. Something really interesting is going to happen in just a second. So if I do time, I only need time for this one, for what I'm about to show you in this moment. So the answer should also be 10,000, right? And it should take about 85 microseconds, hopefully, because otherwise we have all this Haskell machinery that we're paying for, and that wouldn't be fun. Oh, crap. And so now this macro is smart enough now, but it didn't used to be. Look, it took 99.82% in compilation time, and it did a gajillion allocations, and it allocated like 18 megabytes. That's a lot of megabytes. And it took like, I don't know, six. That's a lot of seconds for a computer. And you're like, wait, why did that happen? And so that's like the thing that you can't bolt on to Python that would make it Julia. And that's the the type-based JIT compiler.
Yeah.
Basically, the first time you run a function, it's going to run super cool analysis, and then it's going to cache like all the interesting codes for your specific type signature. So if it ever sees another ham2 string, it's going to know I can reach for the assembly there.
Yeah.
And so the second time you call it, I should not see any of these allocations, and I should see a way faster time. There we go.
Very cool.
And because the add time isn't as precise with like all the benchmarky things, you can just do add benchmark and then do there we go. And so now it was 85 microseconds on the last time, and now it should be there you go. MapReduce is a bit smarter about how it sets up some registers, so this one's even faster than the other one. But like, I have a tool that lets me check that within, a couple keystrokes.
Yeah.
Whereas
cool.
anytime I want to do benchmarking in Rust or C++, it's just like, God, how do I even install this? Like, where do I even put it? And
yeah,
like,
I think
I'm just at
for micro benchmarks, Google Benchmark is really handy, and there's a website called QuickBench for C++ where you can, in fact, if you stick my screen on your stream, I can quickly show.
Yeah, let's do that.
QuickBench. Let me switch over on mine.
I think you're showing up properly. There we go. Yeah.
Yeah, so here you basically you write here's one function which we want to benchmark. We loop over some state which is handed to us by our by the benchmark harness, essentially.
And people just give you the compute like
and then you just say, don't optimize this thing away.
Yeah, you got a black box.
Register this as a benchmark. Do the same here, and then you can just pick your compiler, pick your things, run benchmark, done. Gives you this one was 2.4 times faster than this one.
Wait,
you can see the assembly.
String copy and string created string. Wait, why is it not?
So
what's the difference here?
This one just initializes the string directly. This one creates a copy of it, so it's doing a stitch string has a small buffer optimization, so this will be like this will be a mem copy, essentially. So
famous
this is
23 byte cutoff, right?
Yeah, this is just doing basically the difference between writing hello into here versus doing a mem copy here. That's the difference. But yeah, it's pretty nifty. I like it a lot. You want me to show you the solution to the puzzle that I got?
Yeah. Let's see it. Here, let me. I think because I'm sharing the whole screen, setup got a bit janky, but there we go. We rescued it.
Cool. Yeah, basically I just get the input. I get all the lines for part one. I get all the lines, and then I score all of the lines, and I sum them up. And to score them, I just get the midpoint, split the string, and then there's this algorithm called find first of, which you give it a couple of ranges, and it will find the
common element.
Yeah, and then I just take the priority, which I just do a little bit of character.
Yeah, I did
arithmetic.
Character arithmetic.
And then the second one is very similar. I get all my lines.
See, that's the thing. You chunk them into threes, and then I don't remember which specific method. There.
I use set intersection. So I sort all of my my strings. I use set intersection on the first two to get all of the elements which are in both, and then I do another find first of to find which of the last group is in that intersection, and then I return the
That's
priority.
Pretty cool. How did you set? So you did a set intersection on the on group 0 and 1, and then you did another one on group.
I mean, you could do another set intersection here, but find first of is faster because once you've done you need to do an entire set intersection on the first two groups, but you don't need to do an entire set intersection on the last two because you know that there's only going to be a single element which is shared between them, so you can just do a find first stuff and it's faster.
Is it like it's just gonna do like a linear scan or?
Yeah, it'll basically be like a nested loop.
Mm.
Basically,
Let me.
you like loop over for every element of this range, check all the elements of this range.
Yeah, and that's faster than just trying to get through the set or something.
Yeah, well, it will short circuit. Right, but as soon as it finds the element that it's looking for, it will return. Whereas set intersection has to look at every single element.
Let me advocate for something really cool that I sorely miss whenever I'm going back to C++, and that's Unicode operators.
Mm-hmm.
I know they can exist, but like, look at these beautiful set intersection. It's just
Yeah.
they're sets, and they're overloaded specifically for the fast algorithmic O1 intersection. They also work if you do like linear, like if you do vector. So it's easier if we do 1, 2, 3, 4. Ah, achoo. All right. If we do at cap and then I do 1, 2, right? This will go and find the common thing. Set intersection. If you, however, happen to have done a set here and a set there, then you get a setback. What's really cool is that you can know which one you called if you just do at which, and it'll say, oh, this is an intersect between an abstract set and an iter. Right? So between two abstract sets, it's gonna percolate down into that one. And then if you do this one, you're gonna be like, hey, well, which intersect is this? And it's like, oh, that's the more generic case where you don't have the specific dispatch. And so that's why once you get like Julia, like into the Julia flow, you start to think as like all of these operators and algorithms as like, oh, can I encode this algorithm into types? And so you're like, yeah, you have an operator between these two. That's a really fast. There's a really fast implementation for that case. So write that dispatch case. So you go and you do the set O1 algorithm, and then if you can't, then you write the fallback case.
Yeah.
So you start like patching up algorithmic hot paths all over the place. And so if you can keep on the like hot paths, then you're flying. Just amazing. And you pay no runtime penalty when you do it correctly. Obviously there's an entire runtime for like this system, which may actually get like shaken out so that people are really, really close to doing like good tooling for doing static binaries in Julia. That's going to be exciting because we don't want to ship like the LLVM runtime for every Julia program.
Yeah.
It's getting better. But yeah. All right.
That's
This
cool.
wasn't.
I think that's about an hour now. I'm gonna head off and play. I think my kid might want to play it. It's a free weekend of Witch It at the moment. The video game. My kid's 8, and we were playing it this morning. He really enjoyed it.
Oh, which video game?
It's called Witch It. It's like a hide and seek thing where you have witches and hunters, and the witches need to pretend to be props in the map. And then the hunters have to go and throw potatoes and try and find where the witches are hiding.
Oh, kid-friendly DBD, Dead by Daylight.
Yeah, basically.
Oh, that's really good to know because trying to play